Okay, we're going to be solving inequalities in part 1, and we're going to be working with truth tables in the other at the end. Solving inequalities is just like solving equations, except for the one thing that you always have to remember is to flip the inequality when you divide by a negative. So we're going to subtract 7x on both sides, and we're going to end up with negative 6x is less than negative 24. Notice we're going to have to divide by a negative here. So since we divided by a negative 6, we need to flip the inequality. Graph that on the number line. Open circle to the right. Number 2, we need to distribute before we do anything. So we end up with 4x plus 6 minus 9x. Hold on a second. Kyle Finley is rudely interrupting me. Let me go ahead and pause. Okay, so we're going to distribute here, and we end up with 10 plus 5x. Let's collect like terms. So 4x minus 9x is minus 5x. Variables on both sides. See ya. Minus 6 minus 6. See ya. We end up with 4. Divide by a negative 10 once again. So we need to flip that inequality. 4 and 10 reduce to 2/5. Let's plot that on the number line. Open circle to the right. Number 3, we're going to be starting to get into compound inequalities. This particular one is an AND. So we are looking for overlapping. So let's add 5. We end up with 4 is greater than 2x, which is greater than negative 4. Divide by 2. 2 is less than, 2 is greater than x with less than negative 2. Graph this on the number line. This is going this way. This is going that way. Where's the overlapping occur? In between. Number 4, this time it's an OR, so we don't really care about overlapping, we just care what the answer is. So we end up with x is greater than 1, and x is less than 1. So we end up with the same answer, 1, on both of them, but it's an open circle, meaning 1 can't be an answer. This one's going to the right. This one's going to the left. So it kind of looks like all reals, but it is all reals except it cannot equal 1. Number 5, once again it is an OR. So we are just looking where there's answers at. So subtract 3. 2x is greater than negative 2. So x is greater than negative 1. Over here, we have 5x is less than or equal to 15. So x is less than or equal to 3. Let's graph these. Negative 1 is going to the right. 3 is going to the left. Since it's an OR, we're just looking for where there an answer is. Well, there's an answer from 3 all the way down to negative infinity. There's an answer from negative 1 all the way to positive infinity. I can care less about overlapping. All I need is one true statement. In this case, there's a true statement everywhere on the number line. Hence why it's all real numbers. 6. Notice that the left and the right of this compound inequality that is an AND are pretty busy. When this occurs, we need to set up two different equations. So let's subtract 2x, subtract 2x. I end up with x on the left, minus 5, minus 5. I end up with negative 4 on the right. Let's do the same thing over here. See ya, x, negative 2. Let's graph these. Open, close circle on negative 4, going to the right. Open circle on negative 2, going to the right. But since I am looking for both have to be true, there's only one place where they overlap, and that's negative 2 and beyond. So technically, that is my answer. Because this is only true from here to here for one of the inequalities. It has to be a yes. There needs to be overlapping. 7. Once again, we have two inequalities separated by an or. Since it's separated by an or, we just need answers. We don't need overlapping. So let's distribute first. Then let's add 1. So we end up with 2 less than negative 2x less than 6. So I ultimately end up with negative 1, but I divided by a negative. So all of these guys need to be flipped. Here I'm going to add 1. So 2 is less than 2x less than 6. Divide by 2. This time I'm not going to flip the inequality because it's a positive number. So when I graph this, it's going to be open circles. So we're going to graph both of these inequalities on the same number line. Since it's an or, we're just looking for answers and we're not looking for overlapping. So this is my final answer. Numbers 8 and 9 I did in class with all the periods on gold and purple days, so you can check out your notes for that. Okay, let's look at truth tables. So this is what we're going to do. We're going to do the truth statements for this particular situation. We're going to do the truth statements and false statements for this situation, and then compare those at the very end. Okay, so this one is an and. This one is an or. For this particular one, they have to be true for both. So we end up with TT, so they're both true. I need two true statements. Well, there's one's false, so this is a false, false, false. Over here, it's an or, so I only need one true statement. So true, I have one true statement. I have one true statement. False. Then I'm going to take these two statements and compare it as a or. Once again, I'm only looking for one true. Well, both of them are true. There's one. There's one. Both are false. So once again, this is an and. This is also an and then once we're done, we're going to do an or. So the first one, we're looking at P and Q, so we're going to ignore the R's. I need two truths. True, 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 false, 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 false. They both have to be true. Over here, we're going to do P and R. P column and the R column. So I have true, there's a false there, true, false, 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 false. And then finally we're going to compare these two columns as in OR. I just need one true. I got one, got one, and then everything else has false all the way down. That's part 1, inequalities and truth tables.